Bismillah ar-Rahman ar-Rahim. Today we are going to discuss a very important experiment in our curriculum, which is a self-induction experiment. So what is meant by the self-induction? The self-induction, it is a phenomenon that takes place in the same coil in which an induced electromotive force takes place, such as to oppose the change in the current of the circuit. And of course, if we have a DC battery, the opposition here will take place during the moments of growth as well as the moments of decay, while during the operation of the circuit there is no variation in the flux lines, and according to Faraday law there is no any effect except during the growth on stage and during the decay off stage. And let's move on to another question to understand how does self-induction phenomenon take place. It takes place during, as I have just mentioned, the change of the circuit, but it depends on certain conditions. First of all, the conductor must have a great number of turns, such as each turn interact with the adjacent one. Of course, we have here a solenoid to achieve the experiment, as well as we must have an iron core to output large permeability, and as a result the large permeability will make each turn acts as a small magnet that interacts with the neighboring turn. So here we have conditions to must be considered to pass through our effect, our today's effect. And here we have an experiment. The experiment components: a battery of 6 volt is connected to a circuit of a switch and an electromagnet, and we here make large number of turns, and also we connect the electromagnet in parallel with a name lamp that requires 180 volt to operate. And let's move on to the steps. Of course, the steps is to switch the circuit on, then we pass through the stage of operation, and the second step is to switch the circuit off. Observation: during the on step, we can't observe any change in the circuit, in spite of the change that take place, while on the off stage we notice a tremendous change that take place, which is the lamp will illuminate instantaneously, and an electric spark will pass through the gap of the switch. And we have to explain why, because the lamp requires 180 volt, and of course the supplier only provides the circuit with 6 volt. And let's explain this. During the increase of the circuit, the time of growth is relatively large. This is because the back-induced electromotive force produces a back-induced current in opposite direction to the original current, and of course the current to grow will take a longer time. So it is a relatively long time. This is because the back-induced current in opposite direction. On the other hand, during the off stage, the forward induced current in the same direction, and this makes the current decays very fast with a very high rate. And of course, there is an inverse proportion between the time and the output here, the electromotive force. The time is very short. Let's have a look on the graph here. During the growth, the time is relatively large, and therefore its rate and its back electromotive force is relatively small. On the other hand, in the presence of large number of turns, and this is very important point, and in the presence of a very large rate, why? Because the time of decay is relatively small. We have forward induced electromotive force that plays the role of the supplier to provide the circuit needed to operate it. And that's all for now. Thanks for watching.